What do you think of when you hear space time machine? For most people, this probably conjures up images of something like Back to the Future 2 or a Star Trek transporter. But many other technologies could be used to create the time machine, and we have a few ideas. Let's begin with the video to learn. The James Webb Space Telescope, whose launch is planned for this Halloween, will go back through time through billions of years to reveal some of the greatest mysteries in the cosmos. Heidi Hamel and Matt Mountain, who study telescopes, offer their perspective on the coolest space telescope ever. Hubble is in a low Earth orbit, therefore this telescope will be at the Sun-Earth Lagrange 2 point, which is about 1,000,000 miles away. If you drew a straight line from the Sun to the Earth, you'd have to travel another 1,000,000 miles, and that's where we'll be placing it. The James Webb Space Telescope is primarily kept cool by using large sunshades to block the Sun, the Earth's warmth, and the Moon's warmth. This coolness will allow us to investigate the heat of objects throughout the entire universe. So, the best way to approach this is when you think about observing an object in the cosmos. Here we share information on the James Webb Space Telescope, which is scheduled to be launched in 2018. The JWST is originally developed by the European Space Agency and NASA as the successor to the Hubble Space Telescope. This space telescope will enable scientists to learn more about the formation of galaxies and stars, study supernova remnants and stellar winds, and search for other planets. When discussing it, we usually mention three things that make it unique. One is significantly larger than Hubble. The mirror's individual segments measure roughly 6.5 meters across compared to Hubble's 2 meters. It's bigger than Hubble, and it's colder than Hubble. And that's crucial. Finally, when we joke about how cool it is, it's cool not just because it's a cool scientific discovery, but it's literally going to be a cool telescope because it's made to search for infrared heat from the universe, or the heat from the very first galaxies and stars that formed. Hubble's thermal component of the spectrum. Could you explain specifically why it has to be so cold to capture the kind of light? It's roughly minus 380 degrees Fahrenheit, which is extremely cold. So signals from these faint galaxies, as we'll discuss later, these faint exoplanets are also very faint. Normally, if you're looking for heat, you have to make sure the telescope is properly calibrated. On July 13th, NASA announced that the James Webb Space Telescope had found indications of water in the atmosphere of a hot, puffy gas giant planet orbiting a sun-like star more than 1,000 light-years away, as well as clouds and haze. According to NASA, the observation is the most thorough of its kind to date and highlights Webb's unmatched capacity to analyze far-off atmospheres. There are more than 5,000 known exoplanets in the Milky Way, including WASP-96b. It represents a form of a gas giant that has no direct counterpart in our solar system and is around 1,150 light-years away in the southern sky constellation of Phoenix, the organization stated in a statement. WASP-96b is the puffiest planet in our solar system, with a diameter of 1.2 times larger and a mass less than half that of Jupiter. It is noticeably hotter with a temperature higher than 538 degrees Celsius. According to NASA, WASP-96b makes one complete cycle around its sun-like star every 3.5 Earth days, orbiting it at a distance that is just 1/9 of the distance between Mercury and the Sun. WASP-96b is the perfect target because of its massive size, brief orbital period, puffy atmosphere, and absence of interference from surrounding celestial objects. Webb's immediate and more thorough observation represents a significant advancement in the effort to characterize potentially habitable planets outside of our solar system. Despite the fact that the Hubble Space Telescope has studied many exoplanets' atmospheres over the past 20 years, recording the first clear detection of water in 2013, the WASP-96 system was observed by Webb's Near-Infrared Imager and Slitless Spectrograph (NIRISS) on June 21st for 6.4 hours while the planet traveled across the star. As a result, a light curve that depicted the overall lowering of starlight during the transit and a transmission spectrum that showed the variation in brightness of specific infrared light wavelengths between 0.6 and 2.8 microns were produced. In addition, the light curve supported the planet's existence, size, size and orbit, which other observations had already determined. The transmission spectrum revealed hitherto unobserved aspects of the atmosphere, including the clear signature of water, hints of haze, and proof of clouds that were previously believed not to exist. The starlight filtered by a planet's atmosphere as it passes in front of the star is compared to the unfiltered starlight observed when the planet is next to the star to create a transmission spectrum. Based on the absorption pattern or the locations and heights of peaks on the graph, scientists are able to identify and quantify the abundances of important gases in a planet's atmosphere. Atoms and molecules have different patterns of wavelengths that they absorb, similar to how people have distinguishable fingerprints and DNA sequences. According to NASA, the spectrum of WASP-96b covers a remarkable range of wavelengths, including visible light and a region of the spectrum that has not previously been accessible from other telescopes. It also recorded the most detailed near-infrared transmission spectrum of an exoplanet's atmosphere. Our understanding of the cosmos has just grown. The first image from the newly discovered NASA Space Telescope is bursting with galaxies and provided the most in-depth view of the cosmos ever taken. A picture from the $10 billion auction, the James Webb Space Telescope is farther away from the beginning of time and the edge of the cosmos than any other object that humanity has ever observed. 4 further pictures of the galaxy's beauty taken during the telescope's initial outward scans will be made public on Tuesday after that photograph. The deep field image revealed during a brief White House event is full of stars, with large galaxies visible in the foreground and a new faint, incredibly distant galaxies in the background. The image, which, in the words of President Joe Biden, displayed the earliest documented light in the history of the cosmos from over 13 billion, let us repeat that, 13 billion years ago, astonished him. It's difficult to imagine. According to NASA's administrator, Bill Nelson, the crowded image, which contains several specks, streaks, spirals, and swirls of white, yellow, orange, and red, represents just one little particle of the universe. After the discovery, Harvard astronomer Dmitry Sasolov gave a phone interview in which he stated, "What we witness today is the early cosmos. We've seen this before." Sasolov and Charles Alcock claimed they initially thought. However, they then took a closer look at the image and declared that the outcome was not only lovely, but also worth all the waiting for the protracted endeavor. In addition to the other important molecules like oxygen, methane, and carbon dioxide, water is a highly sensitive component of this spectrum region. The spectrum will allow scientists to quantify the amount of water vapor in the atmosphere, set limits on the abundance of different components like carbon and oxygen, and calculate the depth average temperature of the atmosphere. A glimpse of a massive gaseous planet outside of our solar system, 2 photos of a nebula where stars are born and die in breathtaking splendor, and an updated version of a classic image of 5 closely clustered galaxies dancing around one another are among the sights on display. Last December, the world's largest and most potent space telescope launched from French Guiana in South America. It traveled 1.6 million kilometers in January to reach its lookout point. Then, under the cover of a parasol the size of a tennis court that keeps the telescope cool, the laborious process of aligning the mirrors, getting the infrared detectors cold enough to operate, and calibrating the science instruments began. Thanks for watching! Kindly write your thoughts in the comment section below. Also, subscribe to us to see our next video on Pepsi and Russian military clash.